So folks, we've got one more presentation to go. And I am nominating Wes Lambert as the MVP of Velicon 2022. This is his third presentation of the day. It's spanned, he's spanned pretty much the whole day today, and was, willing to step up and fill in if folks weren't, able to make it. So thanks a lot, Wes. I'll just turn it back over to you for the last presentation of the day. Take it away.
Yes, sir. Thank you. And thank you, Mike. That was awesome. I really enjoyed all the stuff about macOS and all the new stuff that we're getting in there, and so really looking forward to that. But let me go ahead and get my screen shared here and start my video. Okay, well, my video won't go, but that's okay. Let's do screen 2, share. And let's see, slideshow from beginning. All right. So once again, my name is Wes Lambert. I am the principal engineer at Security Onion Solutions, and this is the third talk from me today. Hopefully by now, if you've been here the whole time, I've not bored you too much, but just want to talk a little bit about how we might approach purple teaming with these things called artifacts, right? Kind of a play on the traditional Velociraptor artifact. So let's get started. So again, the overview for this talk is going to be just talking about purple teaming in general, talking about how we might simulate attacker activity using different tools, how we might do that with artifacts, and then kind of getting into the detection and maybe determining our detection efficacy once we have started doing that, right? So without further ado, what is purple teaming, right? I don't know if you know this guy. I grew up with this guy right here, this purple teamer. But in a general sense, I'll claim that I am not the purple team expert, but just to give kind of an overview or just a general statement, I'm going to summarize it as executing a set of predefined actions or tests to emulate or simulate adversary activity, right? And I know there's a lot of kind of commotion, and there are definitely some nuances between attack simulation and adversary emulation, right? I won't get into all that today, but at the first level, it's really executing that set of predefined tests, right? And then after that, we want to be monitoring and determining our detection efficacy, right? Like, did we detect this? Our detection's working, and then adapting as we need to, right? Revising our detections, or going from there and making the necessary changes. So it's that's how we're going to describe purple teaming today, at least. And maybe it's not the most nuanced description, but we'll go ahead with that. So why would an organization, or why would team member security professionals want to engage in purple teaming? We have red teams, we have blue teams, each with their own kind of specialty, right? Their own ways that they affect organizational security and protect organizations, right? So the main thing is really going to be to test those attack chains that maybe the red team, or maybe that the blue team has modeled or threat modeled against the target organization, right? Really, aside from that, is training the blue teamers as far as learning those more red techniques, right? Learning the ways that attackers might attempt to to do things within the network, bad things, and then just ensure that TTPs maybe that have not been tested before are tested, right? Testing the interoperability between security teams, really just fostering overall that collaborative culture between the red team, the blue team, and having them work together to make the organization safer in general, right? And even if it's just a team of one, maybe, or a team of two, having that knowledge and being able to kind of go forward with a way to test those detections and ensure that the detections we have in place are working as we expect. And a great resource for this is Scythe has a great resource called the Purple Team Exercise Framework, or PTEF. It's a great way to kind of go and follow the framework and get an idea of how you might approach this in your organization at a more specific or a more detailed level. Initially, it starts with that cyber threat intel, and then preparing with detections and things like that, and then executing those exercises, and then taking those lessons learned and going from there. And that's at a high level, right? So digging into that a little bit more. These first two I'm going to ignore a little bit, but these other ones I'm going to touch on primarily. But these are the steps that are really outlined in the PTEF V1 summary, right? Like basically, what are we trying to do when we're purple teaming? Like, what is it? What are we going forth and actually doing? So what we're going to focus on here is the red team, or really ourselves, emulating the TTP, the blue team, ourselves, right? And defer analysts, right? Following the process to detect and or respond to the TTP. And then just reviewing to see if those TTPs were identified, documenting the results, going, seeing what worked, what didn't, and then repeating the tests or the TTP, right? And just, continually going and revising from there while testing newer TTPs against the organization's security posture, right? So we'll iterate on that a little bit. Now, I did say, right, purple teaming on your own. So I put out a brief Twitter poll about this because I knew there would be some people that want to get really specific and, are purists, I'm sure. And, again, I am not a purple teaming guru, but I basically asked if one person can facilitate purple teaming, right? If we identify that as purple teaming, or if it's just adversary emulation or attack simulation and determining detection efficacy. I guess they're all the same, but I did get a majority response of absolutely. So therefore, I did continue with this talk. I did not cancel and walk away in tears. So continuing with that, we're going to talk about simulating that attacker activity. Okay. Now, one popular way to simulate attacker activity is going to be using atomic red team, also known as ART. Now, what ART is, basically, this is their quote. It's a library of simple focus tests, and they're all mapped to the MITRE ATT&CK matrix, right? They typically run 5 minutes or less. Most of them come with cleanup commands, so it's very convenient if you're running something in an automated fashion where you don't need, you don't want to have to go behind and do a bunch of manual stuff. And the way that this is leveraged in a somewhat automated fashion is through the use of Invoke Atomic, which is a PowerShell-based framework for developing and executing these tests. Right. So this is how we take the tests that are defined by the community and defined, by various members, right? And then we take those and execute those on a host. How we actually apply these tests to a machine. Here's an example of an atomic test. This is the number one, modifying the registry of the current user profile using CMD, right? Or I'm sorry, command, right? So this is just a regAdd command, right? You can see the various things down here. So just running this essentially, and having that added to the current user profile. So this is something that can be automated, right? Like a machine can do this, Invoke Atomic can do this. We don't necessarily need a human at a keyboard. We don't necessarily need multiple people to go and do this. One person can do this. So let's talk about how we might leverage Atomic Red Team and create an artifact, right? Something that actually uses these tests and applies that logic. So the goal with our artifact is going to be similar to before, right? Execute the predefined tests to simulate attacker activity. And we really want to focus on being able to automate the test execution or to schedule this, right? I mean, we may not be able to do this, all at once. We may not be able to just sit there the whole time and, babysit tests, things like that. And we want to make it easy. We want to be able to do everything from a central location. We don't want to have to be logging into boxes, going to one place or another, trying to look up different things and do different commands, right? We want it to be easy because we're one person, right? Or maybe we have just a couple person security team. So this is a way that, or this is our goal essentially for our artifact. Now, the requirements, go a little bit further, is really being able to select the tests we want to execute, right? Maybe we don't want to execute every single test every single time. We mentioned before that we might want to focus on those particular TTPs, maybe certain type at a time, certain categories of tests at a time. We usually don't want to run everything at once, right? There's a purpose to this. It's to kind of iterate through our detections, iterate through our current posture and see how we can improve that in a process-oriented fashion. So aside from being able to select those tests that we want to execute, we need an engine to execute these tests, right? So we've kind of got an engine in invoke atomic, right? So we can do that from a PowerShell command. It'll go off and run the test and then come back with the results. But how do we take that and invoke atomic, right? And then we need an environment where these tests are executed. Now, I recommend that you don't do this. I wouldn't test in your live production environment, but obviously something modeled after your production environment where detections are able to be replicated, right? The same or similar state. And as I mentioned before, we want the ability to schedule these tests. We want to have control over the execution and whatnot. So enter, with great power comes great responsibility, the Windows Attack Simulation Atomic Red Team artifact. Now, this artifact is pretty cool. It allows you to take these atomic red team tests and invoke the invoke atomic command to execute these tests. And we can schedule this if we want. Obviously, we can select which clients that we have modeled, which things that we want to apply this against. But I want to be very clear in that when you execute these, it's typically not a good idea to run all the art tests at one time, unless you're just having fun or you just want to blow things up. I would try to stay focused really on what you're looking to test, right? And another thing is I would really make sure that you have permission to test before you begin. Again, I would make sure to have a dedicated system at least to test this against, instead of running this on a production or live host. So how do we get this artifact? This artifact is actually automatically generated by a Python script. I did not enter 1,000 atomic red team tests into the artifact manually, because that would be very time consuming to update, right? If updates come out, you have to go manually hand jam that in. It's just not really efficient. So there are a couple artifacts that are already automatically generated by a script. I think the Cape files targets one is generated. Mike might be able to answer that better, but this is just an overview of the script that is actually used to generate the atomic red team artifact. So you can just see here that it'll iterate through all of the atomics that are pulled down from the atomic red team repo, and then it will generate tests for each one of those. And then here's the gist right here. We can go grab that if you want to experiment with it and go run that yourself. But essentially what you would do is just pull down the script. And then I have an example here where you just run it with a /, just straight up art2 artifact.py. And then what happens is in the resultant directory or in the same directory, you'll see the atomics that get pulled down. Don't really clean those up, but this is just to get the artifact built from the most recent source, essentially. And then you can see that the artifact is built, right? The custom art.yaml. So it's pulled down. We pull in all of the latest atomic red team tests, and then we update the artifact with that. And then what happens is you'll see that in the artifact, there are lots of different tests, right? So there's these particular techniques, right? These technique IDs, and then specific test numbers. There are actually multiple tests for some of these, right? So this will actually go through and tell you the number of each test for each one here. And then what you'll see over here on the right is just a table. So this is used in some artifacts also when you have when you're trying to match things against each other, right? You're trying to use it like a column in a CSV. You can use this table to essentially match what you actually want to run. So if I select this test over here, this command will actually run in the artifact. So while you're not running multiple tests at a time in line from a single command, it gives you a lot of flexibility in what you want to be able to run and specify within that collection. Now, we talked about the artifact that we built, right? We can spin it up from that Python script and get the latest and greatest atomic red team artifact. But what about detection, right? How do we detect this stuff, these tests that we're executing? How do we detect this activity? So one way is through the use of EQL. And you might seem like that's kind of weird that I'm talking about EQL and Elastic. I might think the same first time I saw it, but EQL has a fairly structured rule language. It's also got a great way to annotate what the rules mean, what they're looking for, and it's really designed, EQL, or was designed for security use cases, right? So there's a large repository of rules already available. There's a consistent data model, sometimes with, although it's, there's Sigma, right? And I know a lot of folks think of Sigma as far as universal rule language. Still though, like some of the data model, because of the various backends, is not quite clear in every case. So, we're focusing on the equal at the moment, EQL. Here's an example EQL-based detection rule, something that you might use with the Elastic Stack or something like that. Just looking for image load via Windows Update, right? And you can see the different details here: risk score, rule ID, whatever, some tags, and you can also see the query here, right? The actual EQL query. So that's pretty cool. I mean, but what does that mean? I mean, why do I care, right? The cool thing is that Mike did this a while back, and I spoke with him a bit on this. I think this could go a bit further, or still could be improved. With some newer folks getting eyes on this, I think it could really flourish. But the equal to equal project is really something where we take those equal rules, the EQL, and then we convert that over to VQL. And so what it's called basically is converting the EQL rules into a detection matrix, right? And then from there, we're able to convert that into our natural VQL queries and go from there. So it sounds cool, it's probably kind of complicated, right? So we'll get an idea right here of how that happens. So in this repository, there's a Windows Sysmon detection and a Windows Sysmon event detection artifact that basically, if you run this script right here, it's going to essentially convert these EQL based on the log provider, the EDTX log provider, take these rules and convert that into an artifact, right? And the same thing with event detection, the main difference being that the first one is going to be just a straight up, just run it, right? The event detection is going to be a client event artifact. So that's two different ways right now that you can generate that and start experimenting with that. And this is kind of what it looks like from the conversion, right? Now this is on Sysmon data, keep them in mind. So like you'd have Sysmon installed and whatnot. But you can see now the difference and the transformation here from the EQL natively to the VQL, right? And so we can see how this is implemented in Velociraptor and how this is converted. And this is what it looks like essentially. So the resultant artifact is, when loaded up inside of Velociraptor, this is the event detection one. So this is going to be watching for, clients are going to be watching Sysmon logs basically, and then generate these events and bubble them up to the server whenever anything is noticed. Now, I will see it's really just a bunch of different, queries, right? A bunch of different queries, and I could scroll down through that artifact and you can see all the different sorts of queries, but essentially every single rule, right, that was in the EQL repo, at least the one that we were sourcing against for the Sysmon data, into here. All right, now aside from that, let's talk about actually putting this into practice and maybe determining our detection efficacy, seeing how well this actually works in our environment. As you can see, we've got kind of a notion of the atomic red team tests being deployed out to some workstations, and then Velociraptor processing that, right, and alerting us to anything that's strange. Well, the first thing that we'll want to do is, at least for this data set, is we'll want to make sure that Sysmon is installed. And a great way to do that is actually using the Windows sysinternal Sysmon install artifact. It's built into Velociraptor. You may need to customize it for your environment, especially maybe the Sysmon config, right? You might have a certain config that you want to use. I would definitely recommend that. But that's the first thing that you want to get in order, is to make sure that Sysmon is installed and running, right? So that we're actually generating the data whenever we run the tests. And the next thing that you want to do is actually enable the client monitoring artifact for the event detection, right? We want to have that enabled so that whenever we're doing our tests, we're actually watching for this activity and we can see the things that we're looking for, right? We'll get those rows returned as results. And then we'll want to run the atomic red team tests, right? We'll want to configure a collection, and this is really cut off here. I mean, you could scroll down like for days and select whichever test that you want to execute here. And there are also a couple different options here that you can leverage. The first one being install art. This is going to be typically selected whenever you want to install the actual execution framework. It's usually on the first run. You don't necessarily have to do that after the fact unless you reset the box, or something else like AV maybe removes it, right? So another option that you might want to be aware of is remove exec log. So what this does is actually removes the previous execution log from the atomic red team attempts. That way we're not, we're cleaning up after ourselves from the execution perspective and from the results perspective. And we get a clean slate and a clean result set whenever we run it again. And that execution log file by default is in the C Windows temp art exec directory. And this cleanup option right here, again, this is to clean up. This is the invoke atomic native way to clean up the execution artifacts. So usually you'll want to make sure to have that selected unless you have a compelling reason not to. And again, this run all, I don't necessarily recommend it unless you're just playing around, playing with it and trying to generate some detections. But those are really the bulk, aside from the tests, that you'll want to be aware of, the bulk of options. Now, when we run this test, we get a couple things back. It's pretty cool being able to see, actually what tests executed and some different details about those tests. So whenever we run it, the actual artifact, we'll get things like the execution time. We'll get a technique column right here, which is pretty cool. If you actually click on that, it will provide you with an external link to the technique, right? And we'll also get the test number and test name, and then of course the host name, username, and test GUID, right? So these are all different things that we can do to validate that the test actually executed, right, successfully without failing, and then have that kind of information to give to somebody else or to review later on what we actually ran against this box. And then after we've done that, we can review the actual detection results. And this is an example from the event detection. Again, this running on the client. So we're detecting anything within that Sysmon log using all of those VQL queries converted from the EQL queries from those rules. And then we can go off and compare that, right? So we can see what worked and what did not, right? And then we can adjust that as necessary, maybe running the correct test or making sure that the correct detection mechanisms are in place. We have different rules that we want to have implemented. We have the way that the environment the way that we want it. Now, I do want to talk about some detection alternatives, right? So while EQL to VQL, these types of detections are great, there are alternatives that you can also run, again, in a one-shot or convert them to a client event monitoring fashion. And one of those is going to be Chainsaw. So it's a great way to use Sigma against those Windows event logs, right? Things like Sysmon logs to do similar things and to validate your tests, right? Or to validate your detections, right? So like if you wanted to run this as a client event artifact as your detections, you could absolutely do that. So it's just another way to do that. The same thing with Hayabusa. Did I cut off? Oh yeah. So Eric Capano and Whitney Champion, they did a great job with this one. This is a really excellent, essentially a Windows event log analyzer similar to Chainsaw. It works very similarly, very fast. So another great example. And then even more, another great example is Zircolite, just another way to get at it, depending on what your preference is. Again, all of these could be implemented as one-shot detections or as client event monitoring artifacts, however you wish to implement those, although you may have to alter the artifact a little bit, right, to get those to work like you want. So what is on the roadmap for the Atomic Red Team artifact and or maybe similar things? I would like to update the out-of-box detections for the equal to VQL stuff. I would like to expand on some of that work that Mike did. He did an amazing job with that. So I would like to add to that a little bit and see what else we could do there. I also would like to provide some support for Linux and Mac OS. It's as Mike Pilkington pointed out, Windows is not the only OS in the enterprise anymore, right? So I definitely want to have an effective way to test this against Linux and Mac OS hosts. Right now, it is only supported for Windows hosts, so it's just something to be aware of. And just in general, I would like to refine the behavior and the dependability of the tests. Again, as stated in the artifact header, these may not work all of the time, all the tests. So it's just something that you'll have to, test on your own and see what works for you. And, I would love any feedback or any questions that you guys have. But aside from that, I think that's all I have for you guys today. Thank you for sticking with me so long and throughout various presentations if you've been here all day. Yeah, and thank you, Mike and Carlos and everybody else that's put on such a great conference.
Yeah, thank you, Wes. Another wonderful presentation. That did you 3 for 3 today. So thank you very much. Anybody have any questions? We have a few minutes left. I want to make sure if anyone has any questions, either for Wes or for Mike Cohen in general, give you maybe another minute just to throw those in there and then we'll wrap it up. Wes, someone is asking if they can have access to your presentations. Are you going to post them online somewhere?
Yes. I'll probably tweet it out. I haven't figured out where yet, but probably tweet it out either today or tomorrow.
Okay, great.
Yep.
Okay, so we have a question in the Discord channel. What needs to be installed on the endpoint to be able to run ART?
Nothing really. I mean, just, you can run it straight up. So, I mentioned before the Sysmon stuff, right? If you're looking for those detections, but otherwise, I think it might be like a .NET framework or something. Maybe not. There might be a specific .NET framework, but you're probably compatible. But I mean, aside from that, you just run it and it downloads it and it runs, or it should work.
Excellent. But do you need to push the invoke art?
Oh, right. Yeah. So the artifact does that, right? It downloads it.
Cool. All right. Keep the questions coming.